Hello. Ki hal chal sat sri akal. So firstly, yesterday I thought that the linked list questions are very standard, very old, very basic. So for sure that resources would be plenty available. But I saw the people were saying one pass and were having two for loops. Like I was just legit confused that why the hell there is no actual video of telling the solution of one pass. But yeah, then I thought that for sure I will just make the very old and basic problems too, because in this video you're gonna see both the approaches, recursive and iterative. And for sure recursive is easier to understand but have a bit space associated with it, while iterative is a bit hard. In a sense, not hard, nothing is hard. If you are with us, nothing is hard, but it's more tricky to write, to just understand, or just to have it in your mind at one stop. So yeah, without further ado, let's start with the problem statement itself. For the problem is saying swap nodes in pairs. In the last question you saw swap or have the values being swapped, but here it is the nodes being swapped, not values. Cool. And it should be done in pairs, which means last question we have only one swap, that was all, but here we have to swap in every pair. We will see what that means, but meanwhile, okay, let's go on the question completely. Given a linked list, swap every two adjacent nodes, which means every two adjacent nodes I need to swap them down. It will go 2 1, which means this 1 2 will get swapped and the nodes, so it will become 2 1, and this should become 4 3, and for sure ultimately it should all connect. This is what actually we wanted, and return its head, which means the new head, this head, right? You must solve the problem without modifying the values, because the nodes need to be swapped, not values. That is okay, that the nodes also may be changed. Now as we go on to the solution one, for sure the easiest solution, but for sure I told you that it has a caveat, that it has a bit space. So in interview you will start with the easiest solution and then you will go on to the optimization where you actually show the iterative approach. But here in for sure, see, when the process is repetitive, which means okay, for sure you have to swap this part, right? You have to swap this part, you have to again swap it. Then maybe if the linked list would have been longer, which means okay, more nodes, then again you would have to swap it. So basically it is repetitive, right? Same stuff of swapping is in again and again. Remember, again and again you have to do the same stuff. So why you are doing it? Why not using, you can employ a recursion for you, right? It has zero fees. You can employ recursion for you. Recursion will actually swap the rest of the part. You just have to show recursion, okay, how to swap one part. Just show recursion, because see, if you employ an intern or a full-time employee, just once you show him okay how to perform this task, when he understands that, when the AI ML model anything understands that, then the rest of the part it can be done by himself. That is what we have to do, because we saw that the operation was repeating. Thus we said okay, I will just show my process how the one task is being performed, then other entire task, remaining task will be performed by himself only. Cool. What initially I have, the problem says that initially I have is a head, because it is the only thing which is said, and then the list is given to me. So basically this list can be treated on the basis of this head. So it is what I'm having right now. Now as we have a recursion, so we for sure know recursion has three things: a base condition, a recursive condition, and the return statement. So starting off with the base condition, what can be the base condition? We are swapping a pair, so base condition will be that we cannot swap a pair at all, right? So ultimately, when can be the case that we cannot swap a pair? Because ultimately we know that we can swap a pair when at least it's a pair itself, right? So we can swap it. But if it is not even a pair, which means okay, this node is not there, only one node is there, okay, I will say if the one node is there, then it's a base case. And what if the node is not even there? Then also it's a base case. So which means when the head is a null, or when the head is next, which means if I just point to next, it is null, then I can say okay, it has one node and it has no nodes, so for sure it's a base case and you have to return that. Okay, we got the base case. Now comes the interesting part. Now comes the okay, I just assume I just have to swap two nodes. Rest of the part will be performed by recursion. Now to swap two nodes, I need to know, okay, I know, okay, the first node is head, but to swap with the other node, I should be knowing, okay, what is the other node, right? Thus, I just have, okay, let's name that other node, which is the next node to me, as temp. Now, as this node called as temp is the next node to head, so it's nothing but the temp is head next. Now, I have identity of both the nodes, head node and also the node of temp. Now I can just swap it. Cool. So what we will do, I can just have identity of both of them. I can now swap it. But I also assume that the rest of the part answer will be brought by recursion. So whatsoever answer this gets will be brought by recursion. And when I say bring the answer, which means ultimately it will just swap the entire thing down and will point to the new head. Which actually means is that the whole problem is actually being solved by recursion itself. It's just that, okay, for the first, I am just showing him that, okay, it is how you can solve it. The rest is still be solved by recursion, but it is entirely a recursion problem, which means entirely ultimately it will also return what? Head only, which I also wanted. So that's the reason, okay, this recursive part will actually, after swapping, will return a head. And it will point to the first element of this swapped, after swapped. This recursion, okay, it will point. Now I know I have a head, I have a temp, I know that I have to get it swapped. So for sure, firstly, as we know that if we are, because see, to actually link it is only having one thing, so I can't do like this, okay, just if it is here, then I just pointed here and I just pointed here. Like I just can't just swap directly. I have to maintain, okay, they have two pointers, so it should know what was the next location. So firstly, one thing I know that this one needs to be swapped. So ultimately it would look something like this. The number 2 would be here, sorry, number 1 would be here and number 2 would be here, which means 1's next would be 3 and 2's next would be 1. You remember 1's next should be 3, and we also know initially that 1's next is actually this 3, but 3 is not the final node. It is after being swapped. Whatsoever is at this location would be, let's say it is X, it would be there, let's say it is Y, anything. So after being swapped, which means although the location of this element whatsoever will be there, it is head next, but head next after being swapped. So basically head next, but head next, but after being swapped. Thus I have this recursive function which will actually become like give me, okay, you have this new head, now just swap it down, return me what could be the head now because of this swapping, and then I will just say, okay, its next pair is, because I've just wanted one's next to be this person's pointer. So one's next, which means head next, will become what? My swap pairs of, which is the recursive call of what? Head next, because head next points to the third number, this point. That is how I just pointed my 1 to 3. Right now, other as you can see, other pairs, other pointers are as it is. I'm not having that. Now we also remember, okay, 1's next is done, but 2's next also needs to point to 1. But although right now it is pointing to 3, but it should point to 1. So but basically I'll just do is 2's next should point to 1. How was 2 possible to grab? By this temp. So I'll just say this temp next should be head, because you know it was head. Now as simple as that, you will see that you have actually modified your starting part, and you know the right part, which means this part will be modified by your swap, which is the function you call, right, swap pair of this particular head, which is right now pointing to 3. So basically this swap pair will actually solve it. Now ultimately, you know, your head is now a new temp, so ultimately you can return the temp. And that is how easily, by just swapping starting to pairs and assuming that your swap pair head will bring you the answer, you solved it entirely. Thus, looking at the code, very easy. Base case I showed you, exactly same base case. If the head is null or the head next is null, you just return a head. And for sure we had this temp pointer to actually go on. Okay, first node I have, head I have, but I have to swap with the next node, right? So I also need to have a pointer for that, have a temp pointer for that. Cool. Then comes the part. I just pointed, okay, head next should become equal to the swap pairs of head of next, as I showed you here, right? And also lastly is temp next, because ultimately the node 2, it should point to 1 only. The node the node which was temp is its next should point to head, and ultimately I know my new head is temp, so return that head which is temp. So if we just see, we are iterating on this entire list just once, so time is O of n, but it's a recursive call, so for sure it will just go on inside in the recursion and we'll find the answer. So space is also O of n. That is the reason its space is more. And for sure we just know that, okay, we can just, as we saw here also, that we are just modifying this, right? And we are just asking recursion to do this stuff. We can also perform the same stuff, although it would be a bit long for us to understand, but we can also perform this stuff, right? And we can see recursion is nothing but having the function by itself to perform this function again and again. In iterative we can have a loop, any loop we can use, while loop, for loop, any loop we can use. So I can just do the same thing. At one step of the loop, I will just swap these two values, and then I will just maintain, okay, for sure I have to maintain some pointers also to actually swap the next two values, and that is how I will perform my iterative function. By this, what will happen is, as I'm performing iteratively, which means I'm not using the recursive call, recursive stack, that is how I can optimize my space of not using a O of n space. So basically now we will see the recursive part. So recursive part is actually exactly same as iterative part is exactly same as the recursive part. It's just that rather than recursion we are using a while loop, and also it is a bit more that, okay, I have to find what is the new head, because here I just assume that my swap pair will give me the new head, but here in iterative I should actually know what will be the new head later. So that is the reason we will just use the iteration part. Now for sure as we go on and we have to swap this entire thing, and we know that it can be entirely swapped, which means not sure if 1 would be here or 2 would be here, any number could be here. So 1 never assumes that, okay, it is the head. So let's assume, okay, initially it is the node which is at the front, and it will always be at the front. Now let's swap this entire part. That is why I choose this dummy node with me. This D node will actually always be in the front, and it will just swap the entire this part. Thus I have chosen this dummy node that, okay, in the last I can just return the dummies next, and next will just say, okay, the right part is sorted and you're good to go. Now for sure to actually start to swap, firstly what I need is just as I told you that, okay, to swap two nodes I just need to have their locations, but for sure I'm starting with this dummy node itself, so I can just have the pointers to these two, and then I can just shift the pointers to here and here and just swap them. So I just started with addressing the values of -1, which is our dummy node which I made right now. So I just named it as, okay, it is the previous node, it is the current node which I am at right now, and for sure the head is, see, it is the pointers initially, because I made this dummy node, so it is pointing here. Head, it is also pointing here, it is pointing to 1. But what I made new pointers are prev, which means, okay, previous pointer, and the current pointer, which means this previous current will help me, okay, currents next should be this previous, and previous next should be this current. So that is like how I can actually swap it, but it's a high level. But actually we will go on that, okay, firstly I initialized these pointers. How? I just made this dummy node because it was not made, so I just made this dummy node. Now after making this dummy node, I have to also mark my previous pointing to that node. Okay, I marked it. Then I just also have, okay, the node which is the current node, it should point to head because it is the first node. Okay, I just pointed my current node to head, and then I'll just also say that, okay, dummies next should actually be pointing to my head. That is okay. By these four things, I have made this entire structure of the starting. So to actually start working on that part. Now comes the interesting part, which is actually for sure in iterative also you have a while loop, right? While loop needs to end at some point, as we saw in the recursion also, that okay, we had a head, but as we know that okay, head never makes us sure that okay, it is pointing at one. It will keep pointing at one, no worries at all. We have pointed our head to current, and this current will keep on moving because this prev will keep on moving. These two will remain constant, but the prev and current will keep on moving. As the current is keep on moving, ultimately it will just reach somewhere, which means somewhere it can't be swapped. How? As we saw above also, if it is pointing to null or if it is pointing to only one node, which means current's next is null or basically current itself is null, then you have to exit your while loop. That is it. Exactly same as you saw in the recursion also. Now, when the base case is done, which means when the while loop can be ended, now comes the part where actually I have to swap. I know one thing. I need to swap this 2 and 1. So which means the 1 and 2, which was actually right this, it needs to become as 2 and 1. Which means this dummy node -1, its next should for sure be a 2. I also know one thing. Now, dummy's node next, I can point, which means previous next, because it was the node which was previous. So previous next, okay, I need to point to what? 2. But how I can access 2? Simple as, okay, current's next. As simple as that. So basically this previous next, it just points to current's next, and it started pointing to 2. That is how I pointed my -1 to actually 2. So actually that it becomes like this, right? Now you will see that okay, -1 is pointing to 2, but you also wanted one thing, that it is how it should look like. Okay, -1 is pointing to 2, which means my 2 has come at the front, but 1 should, because if you are swapping 1 and 2, so 1 should point to 3 now, right? Now do the same stuff, that 1 is right now pointing to 2, which is the current's next, which is it is the current, it is the current next, it is the current next. Thus I want that rather than 1 pointing to its current next, it should point to current's next, which means my next. Thus I'll just do the same stuff. I will just have it, okay, my current next, it should actually start pointing to my current next, and thus it will just remove this pointer and it will start pointing to my 3. That is how what happens is my 1, it start pointing to my 3, right? And my 2 as I showed above, it is being pointed by -1. So that this pair is done. Now we also have this link from 2 to 3, right? We also have to remove this link and make this link from 2 to 1, because see, -1 is pointing to 2, -1 is pointing to 2, 1 is pointing to 3, and our 2 is also pointing to 3. Thus I want this to be removed and this 2 should point to 1, which means my 2 is pointing to 1, my 2 is pointing to 3, my 2 is pointing to 3. I want my 2 to point to 1. So my 2 is pointing to 3, I want my 2 to point to 1. Simply my 2 is pointing to 3. 3 is what? Current. So basically this is prev next. I have the location of prev. I have the location of prev next. So prev next, whatsoever it was pointed to, just now point my prev next. My prev's next, it should point to current. I just point, okay, my prev's next, it is this location 2, its next is 1, so it should actually be a pointing to 1, which is the current node. That is how I will just say, okay, my prev's next is current. That is, I showed you that, okay, in recursion you only have to define 2 conditions, just swap this, because ultimately recursion was bringing, but here you have to define everything after swapping, which node will be there, which node will not be there, and so on. Now as our it looks good to us, because see, I wanted to swap 2 and 1, my prev is here, my current is here, it looks super good to me. Now I can just start swapping from 3 to 4, but as you saw, as I was swapping 2 and 1, my pointers were at -1 and 1, because see, initially the array was 1 2 3 4, right? So initially my pointers were at the dummy node and 1, so I will just bring these prev and current like here, which means my prev should come to 1 and my current should come to 3. Simply prev is here, so bring prev next. So prev will come to prev next, and also current should come to next, so current should come to next. That is how I can solve. Okay, now it will just a loop problem. Now the loop will actually start solving the further part, and that is how we will solve this problem. Code is pretty simple, and for sure I just said we had this dummy node because we never know that what could be the front node. So what is ever the front node, this dummy's next will return the head, and that is how you can just say I have got the head. Code is pretty simple. These 4 initializations which we saw earlier, then while loop which actually has the base condition, the termination condition, and then the while loop will actually go on, which is simply as I showed you, these 5 steps will actually go on to have all the connections sorted, and thus making our these two nodes pairs, I should say, as swapped. And then ultimately I can just return my dummy's node next, and that would be answer. And you could show, and you saw that and you saw that okay, my time complexity is nothing but O of n and space is nothing but O of 1, because I'm not using any recursive call or anything like that. I'm just using those 4 pointers or something like list node, pointer node, dummy node, and that's it. And that would be just having O of 1 space. That is how I just solved it. Code for recursion for C++, Java and Python is down below. Code for iterative code, which is actually a better code, which actually you have to tell in interviews and stuff, is actually down below also. So that is all from my side. I hope that you guys got the complete intuition. I just drawn the entire stuff step by step. I have seen people just draw in the same diagram. It becomes very confusing, because I have just, and the PDF is down below for you to just refer, because it's actually that a few times maybe you have to just write down in the code, pen, copy to actually understand it. But the PDF, if you just go on through PDF, you will just see, okay, this was the pointer here, now it is being shifted to here. At every step I have just modified the image to show you, okay, now what is happening. So I hope that you guys like this. Take care. Bye.